Hey guys, so we're going to be talking about some special products. So these particular problems, when we multiply them, their answer has a special name. Okay, so this is going to be a couple of pages of notes, at least it should be two. We have some word problems. When I get to word problems, what I'm going to do is turn off the computer or turn off the put on pause the video and then write it out, and then it'll reappear. I ask that you do the same thing instead of wasting time listening to me write it, okay? All right, so let's get started. So the first one we want to talk about is called a square of a sum. So what does that mean? Square of a sum. So basically what that's saying is I'm going to take a binomial where there's addition going on, and I'm going to square it. So first thing I need to do is to recognize that simply just means x plus 2 times itself, right? Okay, so when I do that process, we talked about that in the earlier notes, we have a couple ways of doing it. We can do the just distributive, we can do vertical multiplication, we could also do the area model. So I'm just going to do with distribution. So in this one we get to x times x. So we're going to multiply the x times itself, right? And then it says plus, so we're going to write plus, okay? And then we're going to multiply x times 2. And then we're going to multiply, we're going to write plus again, and then we're going to multiply by the 2, so we're going to have 2 times x. And then we're going to have 2 times itself, which would be 2 squared. Okay? And so we would get x squared. And then notice here, if I rearrange these terms to the multiplication property of, or the commutative property of multiplication, it says that would be equal to 2x. So I actually have 2x that shows up twice. And then I have that 2 squared, okay? So what I end up with for a final answer is I get x squared plus 4x plus 4, okay? So this answer, that's the result of multiplying or squaring a binomial or multiplying a binomial by itself. This is known as a perfect square trinomial, or a trinomial square. Okay, so you should notice there's a couple things going on in this problem. We've got a perfect square in the front, so I'm going to just say perfect square, and we've got a perfect square in the back, perfect square. We do have a plus, that's got to be there, and then if we look at what's in the middle, this middle term is going to be twice the two numbers that were in our original problem here. So we have x plus 2, so we're going to have 2 times x times 2. So we're going to get the same middle term twice, and so we just kind of can cut down to that. So that's a sum of a square, or square of a sum. Now I still have its partner, and that's going to be the square of a difference. So the only change will be the sign that's inside of the parentheses. So for example, we would have y minus 5 squared, okay? So we've got, remember this is just really y minus 5 times y minus 5. So we're going to get y times itself. So y times y is going to give me y squared, so that's what this guy is. And then what's going to be interesting here is the sign. The sign now becomes a minus. So I'm going to highlight him. I'm going to make him red. Why? Because he's a minus. So that's the only big change on this guy. And what I'm going to notice is that I'm going to get y times -5. So that's going to be y times 5. And then I'm going to go this direction, and I get that minus again. And it's going to be 5 times y. And then when I multiply a negative times a negative, I am going to get that plus. So look at your signs here. And then you're going to end up getting y times itself. So that gives me y squared. And then remember we talked about before, this guy can alternate around because of the commutative property of multiplication. And I have not one, but 2 5y's. So I'm going to have minus 2 times 5y plus that 5 squared. So when I do the math out, I get y squared minus 10y plus 25. So again, perfect square, and this guy is going to be double the two numbers that were inside there. So we have 2, and we have a y, and we have a 5, and then again we'll have the sign. So that's kind of the pattern that we're going to see. Okay, so both of these are considered perfect square trinomial or trinomial square. Okay, so again, I'm going to just do it real generically how we do it, algebraically. So the square of a sum let's say we have a plus b we're going to square that. So this is going to give me the a squared because it says plus, we write plus. We're going to get the same middle term twice, and that's going to be the a times the b. And then it's always going to say plus at the end, and then we're going to have the b term squared. And so that ends up giving me a squared plus 2ab plus b squared. And then the square of a difference is going to look similar with one small exception, and that's going to be the sign that's between the a and the b is going to be a minus sign. So again, we're going to take that a and we're going to square it. Now we're going to write a minus, and then we're going to get two terms in the middle that are exactly the same, and they're going to be the product of the two terms that were inside of the binomial. And then we're always going to get a plus, and then we're going to square that second term for a grand total of a squared minus 2ab plus b squared. Okay, So at this point, you guys should be about halfway down the page. So I'm going to go to my next screen and we'll continue on this page. So directions are going to say, find each product. The alternative directions could be just simplify. So we have 8c plus 3d squared. And here's again the thing. We can use any of the strategies we talked about in lesson 8.3. Again, we can distribute so every term from each polynomial is multiplied by every term of the other polynomial. We could use the multiplying vertically, or we could use that area model. But basically what we're trying to get you guys to recognize is a pattern. It's not so much the how to get to the answer, it's to recognize that the answer is a perfect square trinomial. That's going to save you a lot of time when we get into the second half of the chapter. Now we're going to undo all the stuff that we've done in this first half. Okay, so again, I'm going to show it to you two ways. I'm going to do the first problem just distributing it out. Okay, so let's see, let's use nice orange. So we have 8c plus 3d, and we're going to multiply it by itself. So we're going to multiply 8c times 8c. So that math, 8 times 8 is 64. C times itself is c squared. Then we're going to multiply an 8c times a positive 3a. So that's going to give me 8 times 4 is, or 3 is 24. C times a is, write it alphabetically, ac. Now I'm going to switch gears. I'm going to multiply 3d by everything. So 3d times positive 3d times an 8c. Well, 3 times 4 is 24. Is that a D and a C? Oh, I can't even read my own writing. I'm ashamed of myself. It's been a crazy, crazy day. That should be DC. So let me go ahead and change that so it should be CD. Sorry about that. That didn't make sense. Thank you. Okay. So that's going to switch around to CD, and then we have a positive times a positive is a positive, and 3D times 3D, 3 times 3 is 9, D times D is D squared. Look here in the middle, we have like terms, so we get 64C squared plus 24 plus 24 is 48CD plus 9D squared. Okay, now, on the second problem, instead of doing it that way, I'm going to use the pattern that we established, okay? So we have 2x minus 5y, that is squared, okay? So what I'm going to do is I'm not going to expand it out, I'm just going to take my terms. So on this guy, I take 2x and I square it. The sign here is negative, so I write minus. And then I'm going to get two of the same middle terms, and those middle terms are going to be the product of the terms in the polynomial. So that means 2x and the 5y. Now, a negative times a negative is a positive, so I'm always going to get a positive here when I square a binomial, regardless of the sign inside. And then I'm going to get the 5y, and I'm going to square it. So that's what the pattern shows me. And then I just do the math out. 2 squared is 4, x squared is x squared. And then minus 2 times 2 is 4, 4 times 5 is 20, and then I have xy. And then 5 times 5 is 25, and y squared is y squared. And then I'm done. Okay? So it's, again, recognizing a pattern. So here it comes. We've got a problem coming up, and I'm going to go offline and copy it, and then we'll start up again. Okay, so our word problem is what's about to follow. I would suggest you pause and write it down. I'm just going to read through it. Al has a garden that is G feet long and G feet wide. He wants to add 3 feet to the length and to the width. What would be the new dimensions of the garden? And find the area of the new garden. So go ahead, pause, write this out, and then we will continue. Anytime we're given a problem that talks about area, any kind of geometry, first and foremost, we should draw a picture. Try to be somewhat realistic. So it has a length and a width of g. Now we're asked to find dimensions for this guy. Remember, dimensions is simply what's the length, what's the width. It tells us that the guy, Al, wants to make his garden 3 feet longer and 3 feet wider. So basically, he's going to add an additional 3 feet on both of the dimensions, so that now his garden is going to be not just the black square, but it's going to go all the way extend to that red dashed line. So for part A, the new dimensions would be, well, to get from G, and then I'm going to add on 3, and on the left side, G, and I'm going to add on 3. So that's pretty straightforward, right? The length is going to be equal to G plus 3, and the width is going to be equal to G plus 3. Now, if we needed to, we could add the label of feet, right? Because the dimensions include the label. So that's easy. So then the next part asks us to find area. So the area of a rectangle is, we're used to area equals length times width. I am going to tell you that when you get into your geometry class, we're now going to substitute B and H for the base and the height of the shape. And then that's a more generic usage for those two dimensions, and we use them in all sorts of different shapes. Okay, so I'm just going to kind of introduce that to you. So for the area, I would just substitute in the length and the width. Now, because they're the same, I can use that shortcut. So I can look at it as being that quantity squared. So again, what that shortcut says is we're going to take the g, the first term, and we're going to square it. And then because it says plus inside the binomial, we're going to write plus. And then we're going to get 2 of the same middle term, and the middle term is going to be the product of the 2 terms that are inside the polynomial. So we have 2 times g times 3, English. And then the third number, when I square a binomial, is always going to be positive, and in this case, it's going to be 3 squared. Okay, so when we multiply that out, we get g squared plus 6g plus 9. Okay, so then we would say, down here, the area of the garden is g squared plus 6g plus 9 feet, square feet. Remember, area is going to be squared. Okay, so that's the first of the special products. And then we're going to go to the next page. So this one's actually going to get the official title of Lesson 8-4, Special Products. And always get a little bit hesitant when we talk about this one, because then people start treating this the same way as the last one, but they don't work the same. So this one deals with 2 binomials that have the same terms, but the signs aren't the same. So it's not like I'm squaring a binomial, right? Because things are different. So this is the product of a sum, that's the plus one, and a difference. That's the subtraction one, the minus one. Okay, so let's see what happens when I multiply this out. So I get x times x is x squared, x times negative 2 is negative 2x, change my color here, 2 times x is positive 2x, and then 2 times negative 2 is negative 4. So what happens is these middle terms are opposites. And remember, when we add opposites, they zero out. So the end result is I'm left with an x squared and a minus 4. Okay? So let me just go back up here and say a couple things. So product of a sum and a difference, we have the same variable. Both were x. We have the same constant. Both were 2. But what's different is we have opposite signs. When that happens, we're always going to have those opposites in the middle. They're going to cancel each other out, and we're left with the square of the first term and the square of the last term. This is called the difference of squares. Now, there's not two options here. There's no such thing as the sum of squares, because if I had a positive inside the binomial and multiplied it, it would be the perfect square trinomial. So we're not going to eliminate the middle terms. This only happens when I have two binomials, same variable, same constant, but the signs are opposite. Will I get an answer called the difference of squares? Okay. So we're going to see if we have a problem that meets certain criteria, then we can use this idea of, hey, I'm going to square my first term, I'm going to square my second term, and I'm going to get my answer. Okay? So let's say we have this. 2x squared minus 3 times 2x squared plus 3. So I need to look through my list here. Do I have the same variable? So I'm looking at my first terms that contain a variable, and yep, same first terms. Check. 2x squared, 2x squared. Okay? Then I look for my constant. Are they the same? Yep, second term's the same, so I have the same second term. Now, I said the word constant before because in my example, there was no second variable. But it is possible in a binomial to have a second variable. Okay, just to be aware of that. Same second terms. Yep. Are the signs opposite? I have a minus, I have a plus. Opposite signs. Opposite signs. Check. So then I'm going to use the pattern. So the pattern says this. I know I'm going to eliminate the middle terms. I just know it, right? Because I've already proved it to myself. So the pattern is I'm going to take the first term and I'm going to square it. The middle term, or the sign, is always going to be a negative, right? Because when I multiply a positive and negative, I always end up with a negative. So my last term is always a negative. And then I'm going to have the second term. And I'm going to square it. Okay? So that's the pattern. So for our guy, we're basically going to take the 2x squared and we're going to square it. We're going to separate it with a minus because I know my answer is going to have a minus in it. And then I'm going to take the last term, which is the 3, and I'm going to square it. So 2 squared is 4. X squared squared, 2 times 2 is 4, so I get x to the 4th. Minus 3 squared is 9. And that's my answer. And that, again, is the difference of squares. So we have the sum of, we have, oh my gosh, my English. We have a square of a sum, and we have a square of a difference, and then we have the difference of squares. So that's the result. So the answer was we had a trinomial, perfect square trinomial, and now we have a difference of squares. So we're going to do one problem here, and I'm going to do it on the next screen because it's a word problem. So I'm going to go ahead and do it offline and then come back. Okay, so a flying disc shaped like a circle has a radius of x plus 3 inches, aka Frisbee. Write an expression representing the area of the flying disc, be a hole, that's not spelled correctly. A hole with a radius of x minus 1 inches is cut in the center of the disc. Write an expression for the remaining area. Okay, so go ahead, pause it, and write it down, and then come on back. So, just like in the last problem, we said, starting with geometry, always get a picture. Now, there's a couple of assumptions being made. Well, number one, big one, that you know that a disc and what a circle looks like. Number two is going to be the formula for the area of a circle, okay? So I'm going to give it to you in case you don't remember it, but you got to get it in that bean of yours, that's your head, and remember it. So the area of a circle, that's a circle, that's next to the A, is equal to pi r squared, where r is the radius. So to figure out the area, pi is always part of all formulas with area, circumference, area, anything that's like shaped like a cylinder has circles in it, also has pi involved in it. And we're going to have x plus 3 and then quantity squared. Okay. Now you might say, hey, Rosner, I thought we were just talking about difference of squares, but now you're telling me to square a sum. So I'm a little confused why you have this one here. Don't worry about it. They're all kind of related to each other. It's just little tricks. So using our shortcut, I'm going to square x. That gives me x squared. I'm going to multiply x and 3, 3x, double it, 6x. I'm going to square 3, 9. Okay? Now, there's two ways to write this answer. Answer 1 is to distribute pi x squared plus 6 pi x plus 9 pi, and then square inches. Or you could say x squared plus 6x plus 9 times pi square inches. Okay, either way. That was pretty easy. B is the one that gets a little complicated. So now we're going to take that same circle. Oh, that's a beautiful circle. I don't know why I didn't take the path of an artist. I digress. Okay, but then it says we're going to cut from the center a hole that's x minus 1 inches for radius. So that's x minus 1. I'm going to make that larger. That's too small. X minus 1. So when they want me to figure out the remaining area, what they're talking about is the part that's inside the black guy, but outside the green guy. Okay? So it's basically, in words, the area of the whole circle, and I'm going to subtract from it the area of the inner circle, or the inner of the, okay, let's try this again. Let's change this word. The whole disk. That's the surrounding. And then this is going to be the area of the hole. 2 holes, get it? Okay. Oh, that doesn't look nice, does it? Okay. Well, go ahead and laugh, but you know what it's supposed to be. Anyway, moving on. So, the area of the whole disk is pi times the x plus 3 quantity squared, and we're going to subtract from that pi times the x minus 1 quantity squared. Okay. So, we already know what the left guy is, right? We just did it. So I'm going to leave him as pi x squared plus 6 pi x plus 9 pi. And now we're going to subtract from it, and we're going to get pi times x squared is x times -1 is -2 times, or -1, x times 2 is -2x, and then -1 times -1 is +1. Okay, so then I get pi x squared plus 6 pi x plus 9 pi. I'm going to start by distributing that pi, so then I'm going to have pi x squared minus 2 pi x plus pi. Okay, now, here comes the big part. I'm going to take this negative, and I'm going to distribute, okay? So I get pi x squared plus 6 pi x plus 9x minus pi x squared plus 2 pi x minus pi. So look what happens with your pi x squared, negative pi x squared. They're opposites, so they cancel out. I've got 6 pi x plus 2 pi x. That gives me 8 pi x. And then, oh, you know what I did? Look what I did. I'm glad you guys are probably, Rosner, fix it. So, that's supposed to be pi. I'm smelling dinner, and it smells yummy. Okay? And then I have, last but not least, 9 pi minus pi, which is going to give me a positive 8 pi. So the bottom line answer is 8 pi x plus 8 pi square inches. And there you have it. All right, good luck with this, guys. Bye-bye now.